Good afternoon. My name is Johan Daniel Cortés. I am a mechanical engineering student at the University Los Libertadores. This video was recorded on June 12, 2023 for the fluid mechanics class of the teacher Hector Dusan. I will talk about of the principle of Bernoulli and Torricelli uncompressible fluids, as well as some examples of application where these principles are immersed their behaviors and change in terms of energy kinetic, potential, and flow. The Torricelli's principles states that the velocity of a fluid flowing through the orifice of a container is equal to the velocity of a body falling free from height equal to the distance from the level of the fluid to the center of the gravity of the orifice. The characteristics of the fluid for the theorem to be valid is that the fluid must be uncompressible and with zero viscosity and must be subject only to the gravitational force. This theorem is based on the law conservation of mechanical energy, which states that the total energy of a closed system is conserved. Especially, it is a consequence of Bernoulli's principle, and Torricelli's principle can be observed in a wide variety of practical situations. For example, when filling a bullet container with liquid from a larger container, the flow of liquid slows down as it approaches the level of the liquid in the bottle is because the pressure of the liquid in the larger vessel is transmitted to the liquid in the bottle, and the velocity of the liquid leaving the bottle can be calculated using Torricelli's law, using height of the liquid in the larger vessel. Now I will tell you about Bernoulli's principle, which describes the behavior of fluid moving along a streamline. It was stated by Daniel Bernoulli in his work Hydrodynamics, and expresses that in ideal fluid and flowing in a closed conduit, the energy of the fluid remains constant along its path. The energy of a fluid at any time consists of three components. Energy kinetic. This is the energy due to the velocity possessed by the fluid. Energy gravitational potential. This is the energy due to the altitude that as fluid and flow energy. This is the energy that a fluid contains due to the pressure it possesses. Thus the Bernoulli principle can be seen as another form of the law conservation of energy. In a streamline, each type of energy can increase or decrease by virtue of decrease or increase of the other two. This equation allows us use to explain phenomena such as the Venturi effect, since the acceleration of any fluid in an equipotential path with equal potential energy would imply decrease in pressure, and thanks to the effect observed like this often, then they get out of moving car when windows are open, since the air pressure is lower outside the car because it is in motion compared to the inside the car, where the pressure is necessarily higher but apparently contradictorial if the enters the car, but this occur due turbulence and boundary layer phenomenal. From the first law thermodynamics, we can conclude an equation that is aesthetically similar to Bernoulli equation mentioned above, but conceptually different The fundamental difference lies in the operand limits and the formulation. Each formula, Bernoulli's equation, is a balance of force and fluid particle moving through a straight line, while the first law of thermodynamics consists of an energy balance between the limits of a given control volume, which is more general science. It allows expressing energy exchange along a fluid stream, such as friction, losses that subtract energy, pumps or fans that energy to the fluid.